All right, so we're going to start here with number 10, and I'm going to capture the question just so that I have it easily. Oops. All right, and so this is number 10. On this first problem set. So, yard running with the speed of this has a momentum of this. So, I need to show that I understand what momentum is. So my y might start off with momentum is the inertia in motion. And that's about it. Right? I might also want to put that the momentum and the velocity are in the same direction. Because they give me the speed here, not the velocity. So that will hopefully keep me from being confused about it. And they want to know the mass. So maybe I should also show that I understand that mass measures inertia. But really, because it's the book, I know that whenever they say mass, they really mean inertia. But so that, I might leave off that last line. So there's my rubric. I think I hit all the points of it. And now I'm going to do my how. And there's my rubric for my how. This is a reminder. So I need my equation. I would go, where could I find the equation that relates momentum to inertia and velocity? Where could I find the equation though? Yep, on the equation sheet that we have for this unit, right? And I'm not going to pull it up. I'm just going to write it. You're correct. It's momentum equals inertia times velocity. And so I think I'm given the momentum. For me, 19 kilogram meters per second. So 19 kilogram meters per second equals some inertia. And then they tell me the speed. And I know that the speed doesn't have a direction, but I'm not going to worry about direction because the momentum and the velocity have the same direction. So 2.2 meters per second. I can put that in place of my velocity. And then figure out my inertia here. And I get 8.64 kilograms. Which I hope is right, first thing Monday morning. 3, they want 2? Okay, so I'm going to put in 8.6. I have it set to not take off credit. What did I say, 8.6? Even if I put in 8.64, it won't take off credit. It'll just say, you didn't use 2 sig figs. Yay! All right, we're going to go on to number 8 now, which is what is the kinetic energy of this bullet? And ooh, now they're being a little bit mean to us. What's our base unit for inertia? Huh? What's our base unit for inertia? Kilograms. And they give us the inertia in grams. What's our base unit for speed? Meters per second. And they give us in kilometers per second. So they're making us do, and look at the answer. It's in kilojoules. Wow, they're just messing with our metric knowledge all the way on this one. Remember, if you don't know the prefixes, they're on the back of the equation sheet. Man, that equation sheet is helpful. It really is. All right, so I would start off myself with something like KE is energy of motion. That's really about all I would definitely need in here. I might make myself a little note. Work in base units. But that would be just more of a reminder to myself. But the problem's really nothing about anything except what kinetic energy is. So, I'm going to start off with my kinetic energy equation from that handy-dandy equation sheet. Kinetic energy is 1/2 the inertia speed squared. Maybe even to help myself out, I'm going to put 9.0 grams, 9.5 grams. Is that right? Yep. And that would equal 9.50 times 10 to the minus third kilograms. The speed they gave me, 1.50 kilometers per second. That would equal 1.50 times 10 to the third meters per second. And so now I can substitute those in. Most common math mistake will be forgetting that squared term. I don't know why, but that tends to be a mistake. The other common calculator mistake is to use minus rather than negative on when you put the exponents on the scientific round notation there. I got 10,687.5, and I know that's in joules because of kilograms and such. They asked for my answer in kilojoules. I could just go in here and edit this and make it joules, okay? Or I could change my answer to kilojoules. Which one would you guys make more sense to you guys? My choice? You guys are the best. Thank you. All right, I'm going to put my answer into kilojoules just for practice. So that would be 10.7 kilojoules. So I'd move it 1, 2, 3 that way. See if I got it right. Depends upon what type of E it is. Yes. All right, so this is number 9. Number 9. So we have a school bus with this mass. Oh, nice, they gave it to us in kilograms, so we don't have to do any conversions. The bus moves at this. Oh, nice, in meters per second. And then they want to know how fast was this mass, this inertia baseball, moving on, has the same momentum as the bus. So, again, it's all about momentum. So, momentum is inertia in motion. And that's kind of generic. I want to have something that actually ties it to this problem. And I would say the ball must have a much larger motion to match the momentum of the more massive bus. So I've shown I understand what momentum is, and I've shown how that momentum, how that understanding is going to apply to this problem. It also kind of gives me a way in my mind to check. If I don't get a much larger velocity for the baseball than the bus has, I've probably done something wrong. We good on the why? All right, let's go to the how. So, again, from our equation sheet, got momentum is inertia times velocity. For this problem, the momentum of the bus is going to equal the momentum of the ball. So I've employed my subscripts there. And so inertia bus, speed of the bus, I'm going to assume that they're going in the same direction, is inertia ball, speed of ball. Now, I'm not sure where you guys are mathematically. Are you more comfortable if I substitute in values now and then do algebra, or if I do algebra now and then substitute in? Substitute before I do the algebra. Okay, that's fine. So the inertia of my bus is 18,200. Remember, your number is probably different. Kilograms. 11.5, I think, yep. 11.5 meters per second equals the inertia of the bus, 0.142, 0.142 kilograms. I don't know what that is. So then I just do a little rearranging and algebra stuff. All right? And I get, a really big number. 1, 4, 7, 3, 9, 4 meters per second. They're looking for my answer in meters per second. And they want 3 sig figs. So I find that easier in scientific notation. So I'm going to put 1.47 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the 6th meters per second. Let's see if I got it right. So 1.47. Then I'm going to use their helper here. I think that's what I want, yep. Times 10 to the 6th. Yay! Still not happy with how these screen clips are coming in, but I guess we'll live with it. So on number 11, and we've got this baseball, which has this momentum, nicely kilograms and kilogram meters per second, and they want to know the ball's speed. Okay, so my y is going to be so much like the other ones. Momentum is inertia in motion. I'm having like deja vu. What was the one that was like identical to this? Was that 10? Like the first one we did, I think?
Yeah.
Yeah, okay. It's kind of a weird feeling. So I'm going to say something like, because I've got to tie this back to that somehow. How about the momentum and velocity will be downward? All right, that's about all I can say about it. So now let's do some power work. Momentum is inertia times velocity. And you guys, okay, here's the ball, right? It's just going to hit the ground. It's moving downwards. Its velocity is downwards, so its momentum is downwards. Are you guys okay if we call down positive? Is that okay? Okay. So that way, I can just put in the positive values of these. It's momentum 0.62, 2 kilogram meters per second. Its inertia is 0.15 kilograms. Its velocity is positive and downward, so we just put in V. And now I just do and solve for V. And I get 4.13 meters per second. They want 2 sig figs. So I'm just going to put in 4.1 on the computer. Oh, I forgot to box my answer. Oh well, okay. Yay! Another one bites the dust. Alright, so this is number 2. And I've got a train. It's going back and forth. And I'm asked which one is greater, distance or displacement, and then I'm also asked about the distance being covered and the displacement being covered. So this question is all about distance and displacement. So that's what my y should center on. And number 2, so I should probably show I understand the terms. Distance is how far something has traveled. And by far, I mean length of path. And then I should show I understand what displacement is how far I end up from where I started. And I might even put in here something like straight line. Oops. All right. So I'm going to leave time to record the video. In our equation sheet, we've got the displacement is your final position minus your initial position. We've also used the distance formula as just adding up all the parts. So looking at this one, I think it's going to help me to draw a picture. So I'm going to, up here, I'm going to draw a picture. So I have my train starts, and I'm going to call this 0. So this would be 6 kilometers. And then it stops, and then it backs up. And it backs up a distance of 4 kilometers. So, what did they ask me first, distance or displacement? Distance covered by the train. Okay, so the distance covered by the train, the distance is going to equal 6 kilometers plus 4 kilometers, which will give me 10 kilometers. Displacement, on the other hand, where I end up is, well, let's look at my lovely little drawing. I ended up here at 2 kilometers, right? So I went out 6 and came back 4. So my position I end up at is 2 kilometers. The position I started at was 0 kilometers. And so my displacement is going to be 2 kilometers. Let's see if I got it right. Distance is greater than displacement. Yes. Distance covered by the train, 10 kilometers. Displacement, 2.0, because that's for 2 sig figs. And that'll do it on that one.